Something unprecedented is happening inside a vacuum tube in northern China that could make commercial aviation obsolete for continental travel. Can you imagine boarding a capsule that shoots you across the country faster than a Boeing 747 at cruising altitude, but on the ground? While Western Hyperloop companies collapsed and billions in investment evaporated, China quietly built the world's longest full-scale Hyperloop test track and shattered every speed record in existence. From magnetic capsules floating through airless tunnels to systems designed to break the sound barrier, today I'm revealing the 8 most revolutionary Hyperloop projects racing to transform transportation forever, including China's supersonic T-flight that has already surpassed 620 kilometers per hour. Stay until the end, because the technology at number 1 is redefining what ground travel can achieve. Number 8. The European Hyperloop Center. We begin our countdown in the windswept northern Netherlands, where a sleek white tube stretching 420 meters has just changed everything we know about Hyperloop technology. This isn't just another test track. It's the first facility on Earth with a functioning lane switch, the critical piece of infrastructure that transforms Hyperloop from a single line into an actual transportation network. The facility consists of 34 interconnected steel tubes, each measuring 2.5 meters in diameter, maintained at a vacuum pressure of just 1 millibar. In September 2024, Hyperloop sent its first capsule gliding through 90 meters of near-airless tunnel at 30 kilometers per hour. By late 2024, they'd pushed that to 85 kilometers per hour while executing lane-switching maneuvers, setting a new European speed record. But here's what makes this facility truly revolutionary. That lane switch allows capsules to change directions at high speed without stopping. Imagine a highway of vacuum tubes where pods can take exits toward Paris, Berlin, or Barcelona without ever slowing down. It's the difference between a train line and an entire continental network. The vision behind this €30 million facility is staggering. By 2050, HARD projects 10,000 kilometers of Hyperloop tubes crisscrossing Europe, whisking passengers from Amsterdam to Barcelona in just 2 hours. Full-scale passenger operations are targeted for 2030. Europe just built the foundation for a transportation revolution that could make continental flights obsolete. Number 7. The Eurotube Demo Tube. In Switzerland, the nation famous for precision engineering, a team of ETH Zurich graduates is solving the problem that has plagued Hyperloop development from the beginning. How do you actually build thousands of kilometers of vacuum tubes without bankrupting entire nations? Their answer sits at the Switzerland Innovation Park Zurich, a 120-meter test facility that launched its first phase in September 2024, featuring something no other Hyperloop track has attempted. The tubes aren't made from expensive steel. They're constructed from post-tensioned, fiber-reinforced concrete coated with polymer sealant to maintain vacuum properties. The Swiss Federal Council recognized Eurotube as a research institute of national importance in 2021, and for good reason. Their smart mobile factory concept could mass-produce tube segments on-site, dramatically slashing construction costs. ABB has partnered with them to develop the propulsion systems that will eventually push capsules to 900 kilometers per hour. But the real breakthrough is environmental. Eurotube's research suggests Hyperloop could eliminate 95% of emissions compared to medium-haul flights. That's not an incremental improvement. That's a complete transformation of how continental travel impacts our planet. Swiss Precision isn't just building faster transportation, it's engineering the sustainable infrastructure that could make Hyperloop economically viable worldwide. Number 6. Tutor Hyperloop. While Western Hyperloop companies burned through billions and collapsed, something remarkable was happening on a university campus in Chennai. In December 2024, India unveiled a 410-meter Hyperloop test track at IIT Madras. And what makes this achievement extraordinary is who built it. A team of 76 undergraduate and postgraduate students working alongside a startup incubated right there on campus. Union Railway Minister Ashwini Vaishnaw announced the milestone himself, praising the collaboration between Indian Railways, the Avishkar Hyperloop team, and Tutor. The initial tests pushed pods to 100 kilometers per hour through vacuum-sealed tubes using linear induction motor propulsion. Future tests on extended tracks will target 600 kilometers per hour. But here's where India's ambition becomes breathtaking. The Mumbai-Pune corridor has been identified for the nation's first full-scale Hyperloop. That 3.5-hour drive through congested highways, it would become a 25-minute journey. In August 2025, Maharashtra signed a memorandum of understanding with Tutor to make this vision reality. The implementation plan calls for an 11.5-kilometer demonstration track first, then expansion to 100 kilometers. A nation of 1.4 billion people, backed by direct government support, is racing to prove that Hyperloop isn't just possible, but inevitable. India might just become the first country to put commercial Hyperloop into operation. Number 5. SwissPod Technologies. On the windswept prairies of Pueblo, Colorado, a Swiss-American startup just proved that you don't need billions in government funding to lead the Hyperloop revolution. On November 21st, 2025, SwissPod's Aeris-1 capsule rocketed through their test track at 102 kilometers per hour, the highest speed achieved by any active Hyperloop developer in the world. Their facility at Pueblo Plex stretches 520 meters, already the world's largest Hyperloop test track, and when completed will form a continuous 1-mile loop across 43 acres of land. But SwissPod's real genius lies in their approach to infrastructure. All the electronics are built into the capsules themselves, not the track. This passive infrastructure design could slash construction costs to 1/10 of traditional high-speed rail. The company had already set records at their scaled facility in Switzerland, completing an 11.8-kilometer journey at 1:12 scale, equivalent to 141.6 kilometers at full size, with speeds translating to 488 kilometers per hour. That's roughly the distance from San Francisco to Sacramento. What's remarkable is that SwissPod achieved all this with a $13 million seed round, while state-backed competitors spend billions. CEO Dennis Tudor put it simply after their record run. They only used 62% of available power. Private innovation is outpacing government-funded projects, proving Hyperloop can be built economically. Number 4. Transpod FluxJet. Canada has entered the Hyperloop race with something that looks less like a train and more like a missile designed for passengers. The FluxJet, unveiled in Toronto in July 2022, promises to do what no ground vehicle has ever done: travel faster than a commercial jet at over 1,000 kilometers per hour. The numbers behind this project are staggering. Transpod has secured $550 million in funding, becoming the first Hyperloop company to confirm
financing for a billion-dollar infrastructure project. Their target:
the 300-kilometer corridor between Calgary and Edmonton, currently a 3-hour drive that would shrink to just 45 minutes. Each Fluxjet capsule carries 54 passengers and 10 tons of cargo, using linear induction motors and a proprietary guidance system called valence flux to maintain stability at extreme speeds. The total project cost is estimated at $18 billion, but Transpod claims tickets will cost 44% less than equivalent flights. In October 2025, Transpod announced partnerships with Algoma Steel and Supreme Steel to advance construction. The environmental impact is equally impressive. The Calgary-Edmonton line alone could eliminate 636,000 tons of carbon emissions annually. Canada is betting that the future of continental travel won't happen in the sky. It will happen inside vacuum tubes, connecting cities at speeds that make domestic flights obsolete. Number 3. Hypertransfer.
Italy is about to become the birthplace of the world's first commercial Hyperloop, and this isn't speculation anymore. In June 2025, Governor Luca Zaia of Veneto made the announcement that changed everything. The feasibility study is complete, validated by the University of Padua and Italfer, and construction of a 10-kilometer test track has officially begun. The project connects Venice Mestre to Padua, backed by a consortium called Hyper Builders that reads like a who's who of Italian engineering. Webuild, the nation's largest contractor, Leonardo, the aerospace and defense giant, and Hyperloop TT, the Los Angeles company that has been chasing this dream since 2013. What makes this different from every other Hyperloop announcement? Government commitment. Italy's Ministry of Infrastructure, the Veneto region, and the Venetian motorway concession are all behind it. Governor Zaia declared it plainly. This is not a futuristic vision, but a concrete project born in Veneto. The system is designed for both passengers and cargo, expandable across the entire region. After a decade of Hyperloop promises that went nowhere, Italy is actually building one. The Mediterranean is about to witness transportation history being made. Number 2. China's T-Flight. Before we reveal the ultimate achievement, you need to understand what China has already proven possible. In February 2024, the T-Flight Hyperloop capsule screamed through a vacuum tube at 623 kilometers per hour, shattering Japan's legendary SC Maglev record of 603 kilometers per hour. The world's fastest superconducting Maglev vehicle now belongs to China. The test took place on a 2-kilometer track in Datong, Shanxi Province, the longest full-scale Hyperloop facility ever constructed. The surface flatness tolerance, just 0.3 millimeters. Construction took from April 2022 to November 2023, built by CASIC, China's largest missile manufacturer with annual revenues exceeding $37 billion. In October 2024, they achieved another breakthrough, successfully testing the capsule in low vacuum conditions for the first time. Air resistance dropped from 15 pounds per square inch to approximately 1 pound per square inch, validating the core Hyperloop principle at full scale. But here's what makes this entry merely number 2. That record-breaking 623 km per hour run. It was only phase 1. What CASIC is planning next makes this achievement look like a warm-up exercise. Number 1. China's supersonic T-Flight. Meet the machine designed to break the sound barrier on land. CASIC isn't satisfied with the fastest Hyperloop ever built.
They're engineering a capsule that will travel faster than any commercial aircraft in the sky. Phase 2 calls for extending the track to 60 kilometers and pushing the T-flight to 1,000 kilometers per hour. That's faster than a Boeing 747 at cruising altitude. The 6-hour journey from Beijing to Shanghai, reduced to 90 minutes. The 4-hour drive from Beijing to Datong, under 30 minutes. But the 3-step strategy reveals ambitions that seem almost impossible. First, 1,000 kilometers per hour, then 2,000, breaking the sound barrier at Mach 1.6. The ultimate vision, 4,000 kilometers per hour, creating intercontinental plane train networks that would make transcontinental flights obsolete. CASIC holds over 200 patents in Hyperloop-related technologies, combining decades of aerospace expertise with railway engineering. They call it near-ground flight. Superconducting magnets lift the capsule, while vacuum tubes eliminate virtually all air resistance. The result is something humanity has never achieved: supersonic ground transportation. China isn't just building a faster train. They're inventing an entirely new mode of transportation that could reshape how civilization moves across continents. This is the future of travel. What we've just witnessed is nothing less than a global race to reinvent human transportation. From Swiss concrete tubes to Indian test tracks, from Italian valleys to the plains of Colorado, engineers across the planet are chasing the same dream: capsules that fly through vacuum tunnels at speeds that make airplanes look slow. But China isn't waiting for the competition. With the world's longest Hyperloop track already operational and speeds exceeding 600 kilometers per hour already achieved, they're building the infrastructure for a future most countries can barely imagine. The question now isn't whether ground travel will surpass air travel. It's whether the rest of the world can catch up before China rewrites the rules entirely. Which of these projects amazed you most? Subscribe for more technological breakthroughs